I need someone's hand to lead me through the night. I need for someone's arms to hold.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So at this point, I wanted to take a little break from monosaccharides and talk about Fischer projections. The reason for this being that Emil Fischer, which is the guy that came up with these projections, determined the relative structure of D-aldoses, which is what we're going to talk about in a second, and he uses these particular projections. And so I wanted to show you guys how to draw them before I actually get into talking about the aldose family. And so Fischer projections basically represent a 3D molecule as a flat structure, where a tetrahedral carbon, something like this, is represented as two cross lines. As you can see, this vertical line is going back behind the plane of the page, and this horizontal line is coming out of the plane of the page. And the central thing between the two crosses is the carbon, and then all of the edges are substituents, whatever's bonded to that particular carbon. And thus we can draw it out like this, where the horizontal line is coming out of the page and these dashed lines are going behind the page. And so as an example, this is glyceraldehyde, and it has a stereocenter right here, right? And so this carbon has two groups that are coming out of the board and two groups going behind the board. After you draw it out in this format, you can actually draw it in a simpler form, which is just these crosses. And so all the different molecules you see of carbohydrates look like these cross structures for the most part. And nobody really draws them out in the 3D structure because it makes it really complicated, especially when you have hexoses or pentoses with a lot of different carbons. And so another important thing is that Emil Fischer guessed that D-glyceraldehyde had an R configuration, and he confirmed this in 1950 via someone else doing crystallography. And so using his Fischer projections, he was also able to guess whether something was going to have a D or L configuration. And he actually got the Nobel Prize in 1902 for chemistry. And so you should practice drawing some Fischer projections where you look at something that's tetrahedral and then draw it in a cross structure. And again, you can use your molecular structures to help you, where you build something like this, which has a tetrahedral molecule. You can look at it so that two substituents are coming towards you and two substituents are going behind, and then you can just draw the cross structure.